Okay, so I don't know how you guys are feeling this week. Is it finally getting to the point where there's a lot going on and you're juggling it all, or is it feeling quite manageable? Hopefully, the later that it's manageable and things are finding their place. It's always, I think, that beginning of a semester is the hardest part. There's a lot to do and a lot to get on top of things and so on. So don't worry, you're already doing better than half of the others. So this is the plan that I had for today. Just quickly kind of reflect at where are we in terms of the course as a whole. Have a look of bit of what we're focusing on this week. I always want to show the due dates and the assignments, but really digging in and spending the most of the time looking at the key concepts that we have for this week's chapter. Like I said earlier on, I think that endocrine system is often the chapter most students find challenging, but there is stuff in this chapter as well. And as you can see, I probably listed everything possible I could imagine on those tick mark list. So first of all, in terms of the systemic approach and then the clinical approach, what we need to know. And I want to spend a little bit of time today also to talk about the next week when we have our first exam and first practical coming up. And I will give multiple opportunities for you guys to take part on reviewing. We'll do one on Monday morning, and I think that if nothing changes drastically, I'll try to schedule another one probably Monday evening, but that's, I'm open to that as well if someone says that Mondays are absolutely out of question. And we'll have a look of what's expected, what happens next week in terms of the exam. I always want to remind of the chances of getting one-on-one or group support, and we also have the tutoring services, and then leave time for the question and answer. But I think that now more than even before, I want to spend some time this week on this week's session going through the material. If anyone has any burning questions at any stage, don't hesitate to give me a shout out. So I'm not saying that all the questions have to be at the end. I'm totally happy to address them as they come. I hope that sounds like a good plan. If it doesn't sound like a good plan, give me a shout out. It's not, like I said, anything like in a church or in a wedding that speak now or forever be quiet. That's not quite where we're heading with this. I'm just checking. We're still recording. Everything's going good with that. I wanted to start by saying thank you. First of all, thank you for those of you who joined me on last week's Wednesday when we had the Cisco WebEx down and we had to jump in all of a sudden to the Google Meetings format. It was amazing that few of you actually made it there. And it was even more amazing that few of you made it to the Friday. I think I had an extra review session as well. So I really, really appreciate that. I realize that everyone has busy schedules and everyone has lots going on. So don't feel ever that you have to physically be here. I think it's more beneficial for you, but also the videos are going to be available. And if you feel that this time is tricky, don't hesitate to tell me where and what day and what time you would like to meet. I will facilitate that. This is just a date that I literally picked out of the random based on, I think, that what our course lead had. I totally copied her appointment time. So there's no bigger reason or secret behind it. So feel free to join. Thank you, Tia, for joining us. Let me know what works for you. That's essentially what I'm trying to say. That was a very complicated and long-winded way to say it. So last week we had 4 pieces of assignments. But this week we're going to up the game and we're going to have 5 different pieces of assignments. But before that, consider that next week you're almost already 25% through the course material. So we have 4 different lecture exams and then the final. And I'll talk about the final later on, but it's nothing of that you have to worry. It's going to be a little bit of a different format. But being done 1/4 of the course, that's a pretty good place to be at. So you've gotten through what I'd say the hardest part of the semester. So don't give up at this point. That's, I guess, that my pep talk. This week, like I said, we have 5 different assignments. They all should be accessible through your learning management system to Canvas, and they do link to the publisher's website. They are all due at the end of this week on Sunday evening. I think that a minute before midnight, if I remember correctly. That's usually how we set them up. And you can see the points distribution there as well. But really the key secret of making it on these online classes is just getting stuff in. And like we discussed last time, the LearnSmart, as long as you get it done, you'll always get 100% for that. A lot of those others, remember as well, you have all the materials, you have all your notes, you have anything you can find from internet, anything available, you can phone to a friend, whatever. So these should be doable things. And if you get stuck, nothing prevents you also from reaching out to me, and I'll be happy to work with you through some of the assignments if you feel that something's difficult. I know that past week I've been super busy with a few other things, so I've not been quite as quick at responding and quite as responsive as I normally want to. But nothing prevents that we couldn't work as a study group or study team either. So don't hesitate to let me know if you get stuck. I don't want anyone feeling that there's no support available. We definitely are here to make sure that you succeed. And like I've said throughout the entire thing, my goal is that you all can get an A. If you do, then work for an A. There's no curve, there's no pressure for me to give any other grades. However, you do need to do the work so I can justify that to my bosses as well. Let's have a look of what I wanted to spend the majority of this meeting time was to go through the key points of the chapter on blood. How did you find it? Was it tougher than you thought, easier than you thought, or kind of along the lines that you expected? Or do you have any particular big questions, big themes? Like I said, I'll go through the key points that you need to know. I'll go through, on this chapter, there's quite a lot of clinical examples of when things go wrong. So we'll have a look of those as well. But if there's a particular concept, I don't want to just take your time and speak of what I think is important. I also want to give you a chance to vocalize. So feel free to shout out. And if you don't shout out, then I'll just go based on what I think. Well, on that assumption, I'm going to make a start, and maybe later on as we're going through stuff, things come to your mind. So a lot of the material on the chapter about blood, I think, is revision if you've done high school A&P, even general bio. There's not too many curveballs, too many new stuff. We might be expanding on certain concepts a little, but it is fairly basic, and I want to keep it that way. I just want to add to what we already know. That's been found out to be the best possible way to learn, that we have something and then we just build up on that. So I think that I'm just uploading, actually YouTube is ticking away on the background, so all of the lecture videos that I normally offer, I didn't upload them yet, and I didn't upload yet the study guide, but they are coming up. I don't know if they are something that you find useful and find helpful, hopefully so. I have some weird timings here since I was recording a video and copying these from there, but what I want to start is by showing that for next few modules, we'll be focusing on cardiovascular system. provided that I get this to pause there. And we'll start by looking at the blood. And that's really the content of this module. Blood can be seen as a kind of a transport media for cardiovascular system at large. That's the stuff that actually gets moved and that carries the materials that we want to transport from one part to another. But blood on its own would not do much of a good unless we would have a way to move it around. And moving the blood around is then that function assigned to the heart. You can think of a heart a little bit as a pump that drives the blood forward within this closed loop system. There's many different animals that have different adaptations. Not all animals have closed cardiovascular system. Most animals have one directional system like we humans, but there are also animals that don't have just a single direction where the blood or alternative to the blood would be flowing. And then, of course, finally, we have our tubing, which is the blood vessels. I'm sure you all have heard about arteries, veins, and capillaries. We'll add a little bit of that, expand a little bit on that, and have a look of more of a finer level adaptations on each of the blood vessel type as well. But this is kind of putting it all to a bigger concept. So all of these coming modules and chapters are linked, and they have things that they share. And basically we need to know all three to be able to understand fully any of those independently. So it's again one of these things that I say that, oh, this might become clearer later on, but we'll try to make everything as clear as possible, even from the very start. I have a definition that I digged out here about the blood as an internal transport system of the cardiovascular system. I think it is a fairly good definition. However, it overlooks few of the other important aspects. I would say that there's two other important aspects that I at least want you to know about blood, in addition to the role in the transporting materials. But this is probably the easiest way to start and the most obvious one that people often think when we talk about blood. What's the role of that? So what sort of things would blood transport? You can type or you can shout out, or then you can just wait and we'll awkwardly all sit. No, I will answer.
Oxygen, glucose.
Perfect. Thank you, James. So blood transport, one of the biggest things that we always think of is the gas transportation. So oxygen and carbon dioxide. So we need oxygen for the cells to live, function, do their job, and we end up as a byproduct with the carbon dioxide. So those are the two that people always think. And I was really impressed that James said also the glucose. So we are transporting nutrients and materials also for various different parts of the body, so we can produce energy where needed, or we can build up structures where needed. And we are also then removing whatever is left other than just the carbon dioxide, other metabolic waste as well. Can anyone think how the last chapter would relate to the blood? This is really a leading question. What could blood transport? Well, blood transports also all of our hormones. Remember that. So, whereas when we saw that hormones travel throughout the body, it is within the blood that hormones travel. And for that reason as well, blood is not just about keeping the cells alive. It's definitely about the communication system. blood is also not just transporting hormones, but messages from elsewhere in the body. If we start, for example, building a lot of toxins somewhere in our body, we will be then able to sense that. Or if you think of the immune system reacting towards pathogens, diseases, blood transport all that information, but it also transports the immune system cells. And we'll have a look of those very briefly today and then in more detail later on. But that's essential route of travel for also protective functions that we have. If we have looked in the back of our early introductory bio classes, I think many of you covered some sort of a chapter about how water is super important for life. And you remember that water transported also many other things, such as heat. Well, most of the blood is water. So again, that's where we're able to pass the heat evenly throughout the body. So blood does a lot more than just transport the oxygen and carbon dioxide, but it is definitely an excellent transport media. So that's probably a good place for us to start. This next one kind of expands on that. So we saw that we had the transport, which we already covered, but in terms of regulation functions, we need to have a certain amount of fluid in the body, not too much and not too little. If there's too much or too little, that can cause significant issues. I'm sure many of you remember, and if you don't remember, I will tell about that later on this course, that you can die just from drinking too much water in a short period of time. So that can kill you if you have too much fluids in your body. That goes to our discussion that you might remember from the introductory courses about tonicity of cells. You might have hypertonic or hypotonic cells, and both would be an issue if you have too much fluid flowing into the cell, or if you have too little fluids so that the cells are starting to dry up. So blood is mainly made of water, and for that reason, blood plays a major role in the regulation of the fluids. I already mentioned the heat a little bit. If you think about it, when we are feeling super cold, there are the vital organs that are usually kind of more towards the core of the human body. We have our brain, we have our heart, lungs, and so on. We want to protect that those are always maintained within appropriate temperature. However, fingertips, nose tips, ears, if you lose that, yeah, it's kind of, I was going to use a word that I'm not supposed to use as a teacher. It's not great, but we can live without those. So we regulate where we send that heat. If heat is in short supply, if we are losing a lot of heat and we want to preserve some, we probably direct blood to those vital organs. If we look like we're overheating, we direct a lot of blood to the external surfaces, close to the surfaces of the body, close to the skin, so the heat can be then directed away from the body. Another interesting one that I think is very important for us to note relates to the pH of the blood. If you look at the range of pH that blood normally is from 7.35 to 7.45, that's a very narrow scale. And there must be a way how we keep the body and blood pH within that narrow range. And we'll talk about that a little more when we talk about fluid balance, when we have covered the urinary system. But this kind of leads me to question that sometimes people tell me that, oh, they're changing their body pH by eating something or doing this and that. And I don't think that it's exactly what they're meaning. They might mean that they eat foods that have a certain pH and are beneficial for other reasons, but you're not really going to change your body's pH drastically based on what you eat. At least not changing that and staying alive. And the final function, we already touched upon that, the protective role of the immune system, for example, that blood has, also the blood clotting. So those are also just as important roles as the transport. But if you look, this division is a little bit of artificial. I think that the protective functions also relate to the transport functions, regulatory functions to the transport. So they're all a little blended, but try to notice that it's much more than just transporting oxygen and carbon dioxide. If you're wondering what I'm looking around, my cat just jumped there, so I'm hoping that she doesn't knock over stuff. If that happens, I'll log back in. I think that this is a good introduction to the functions, the important points to know about blood. Is there anything about these that you feel a little unclear? Shout out or drop a line. Otherwise, I'll just continue the quick review that we'll do today. Well, this next slide, next slide that I have lists what blood is made. And as you see, more than half of the blood is made of plasma. Plasma is this liquid matrix where everything else is floating about, mixed within it. And if you've ever seen plasma, for example, plasma transfusions, or for other reasons why plasma might be collected, you'll notice that it's kind of this transparent, kind of a yellowish, a little stickier fluid than water. And the important role of the plasma really is to function in terms of transporting everything else, but also being the main component of where the water is. Majority of the plasma, over 90% of it is water, simply. And then we have a bunch of other things that are dissolved there. But really the most important three things that we need to know what are dissolved within the plasma are our formed elements. And you see on this test tube, we have plasma separated at the top and formed elements at the bottom. And this is actually how we would normally look at blood sample initially, once it has been drawn from you in a medical setting and we have put it through a spinning in a centrifuge. We end up separating the different components of the blood by that simple method. And we would notice that just under half of the plasma is formed elements. And by the term formed elements, or just under half of the blood, not plasma, half of the blood is formed elements. And formed elements refer to something that's concrete, something that's not just a liquid, that's tangible in that sense. And if you look at the formed elements, majority of the formed elements is then red blood cells. And we should be using correct terminology since we are now at this level, college level of classes. So those are our erythrocytes, but I will often abbreviate them also as RBC because I just think that no one has time to write out red blood cells every single time. But majority of the formed elements is red blood cells. So red blood cells must have an important role. And we'll consider that role in just a second. The other two components that we find within the formed elements in this kind of a layer, whitish layer in between the plasma and red blood cells are our leukocytes and platelets. Leukocytes are our white blood cells, and platelets have a role in the clotting of the blood. So I said that we'll think a little bit about the function of the red blood cells. Well, with the red blood cells, the main function is now the transportation of the gases, oxygen and carbon dioxide. And we'll have a look of the shape and structure of the red blood cell because that's adapted. Again, you remember form and function work together, anatomy and physiology. The shape of the red blood cells is ideal for their role of transporting oxygen, carbon dioxide, and We'll talk about that in a little bit, and I have two different clinical examples relating to that as well. And some of them are ones that I will mention to you what you want to know in terms of the exam, what might come up. Leukocytes are white blood cells. Well, we already kind of touched upon that. White blood cells play a role in the body protective functions. So immune system, we'll have a look of them in a greater detail in another context, but today we want to be able to identify all of the white blood cell main categories. What do they look like? And like I said, the platelets were the last group, all to do with the clotting of the blood. And this is kind of what you would see when you do a blood smear on a microscope. And this is the part where I feel that it's such a shame that we're not able to meet face to face. You don't get a chance to prepare your own slides. So you just have to take my word that this is what you would see on a microscope when you look at a drop of blood that has been smeared all over the microscopic slide. This would have been then also stained using a very basic staining process of H&E staining. That's a skill as well. That's a useful skill to have, and hopefully we'll get a chance for you to practice that, even though not on this course, on some of the future courses when hopefully the world has returned back to normal. So let's have a look what we can see on this picture of the blood smear. Well, most of it is white space, this white stuff between everything else. And that's the plasma. So when we prepare a microscopic sample of a blood, we end up seeing that plasma is kind of left invisible for us. The stains don't really attach to that, but we remember that the function of the plasma was simply to be the matrix, simply to be where the all other elements are dissolved into, or where they are present. Well, the second most numerous thing that we see, and the most numerous of the formed elements, are those red dots. And they're kind of big, but not the biggest elements that we can see on this slide, but they're very, very numerous. And these are our red blood cells. And if you look at them, they all stain red, with the center usually a little bit paler. And there is a reason why the center is a little bit paler, and I'll show it to you in the next slide. And that has all to do with the shape that red blood cells are. So already on a microscopic level, when we're just looking at it with a light microscope, we can already start to get a clue what their shape is. And you remember red blood cells, the big role was to transport the oxygen, carbon dioxide. So that's why they're so numerous. That's the big, big, big role of the blood. The third component that I want to highlight here are our white blood cells. And you'll notice that there's only 2 white blood cells that I can spot from that picture. They are bigger than red blood cells, but they also have their insides, the nucleus within the white blood cells, stained on dark bluish color. So that's the clue when you're trying to identify what is a red blood cell, what is a white blood cell. In red blood cells, we don't have a nucleus, whereas on white blood cells, there's a nucleus present. And we can then classify the white blood cells into different groups based on how their nucleus looks like and how the cytoplasm of the white blood cell looks like. Is there granules or not? And we remember white blood cells' function was all to do with protective roles in the body. And the last components that we can see here, and that might be a little hard depending on the resolution of your screen, there's tiniest dots every here and there. They're more numerous than the white blood cells in this smear, but they are far, far, far lesser in numbers than the red blood cells. And these small dots that have stained a little darker than the red blood cells, they are actually our platelets, and they're not a full cell, they're just fragments of a cell. So platelets are just small pieces that are still able to do their job, which was all to do with the clotting of the blood. And I can actually share just really quickly that I don't produce platelets. My body doesn't produce platelets, so I have to take artificial platelets. What do you think would happen if I didn't take? I was just trimming my cat's hair. If I cut myself, I would just keep bleeding and bleeding and bleeding and bleeding until I would probably die. Hopefully not so. So there are certain conditions where just having this basic knowledge helps us to treat that. So that's why we always have to start with the basics before we get to the fun stuff of dealing with diseases, dealing with conditions, and so on. So those are what you would have to know in theory level and what you would have to know in terms of spotting them from the picture. Do we have any questions of those? I'm just going to solder on then and talk a little bit more about the red blood cells. And all of these slides that you see here are from the bigger presentation that I'm just uploading onto YouTube and then linking to your chapter notes. It's not necessary to watch them. I'm just providing them in case they might be useful for you. So red blood cells look like balloons that have been squashed and then squeezed thinner from the very middle part. So red blood cells, they don't quite go through the very middle part, but they are definitely squashed from the middle. They're kind of discs. The term that we use to describe them is a biconcave discs. So on both sides, it's caving in the middle part. And this shape is really important because this shape allows us to fit in there hemoglobin, which is made of 4 different units. And having those 4 different units allows one hemoglobin to carry 4 different oxygens. So oxygen atoms. And the shape is ideal for fitting maximum amount of gases for that space. There's another reason why the red blood cells are also looking like these squashed discs. The other reason is that this shape allows them to squeeze through the smallest of the blood vessels that we have in them. So if they were simple round structures, they would end up stuck there. But this shape allows them to go to everywhere where we have blood vessels without getting stuck on the way. Another thing that this slide shows, which I kind of like, is, it's good to say that I like it since I did it, is the oxyhemoglobin and deoxyhemoglobin. So hemoglobin takes most of the space within the red blood cell. And sometimes you can see that people talk about the blood being a different color depending on whether it has a lot of oxygen or whether it has very little oxygen. Well, really, you're never going to see blood that's bright red and blue like in these comparisons. The color difference is a little bit more subtle, but it is visible. So when we have blood that's very rich in oxygen, for example, if someone were to cut their artery and blood to the arteries is coming from the heart, but before that from the lungs, so it's highly oxygenated, highly rich in oxygen, that would be bright red blood. If you think of the videos, movies that you might see, that's the bright blood flying out. Do you have any questions, anyone? I just wanted to make sure I saw some of the microphones popping up, popping down. Just shout out if you end up with a question. Deoxyhemoglobin is darker in color. It's kind of not bluish, but more purplish in color. And that's because the hemoglobin within the red blood cell doesn't carry any oxygen. So that has a direct effect to the color of the red blood cells that we see. So I think that this is very basic stuff that you probably already covered. So don't feel overwhelmed. If there is something new, something confusing, give me a shout out again. I encourage you to do that. We're moving towards the clinical aspect that I want to highlight. And this is something that you might want to be aware. It's not the most important thing that has ever existed, but it might be something that I really enjoy talking with the students. And if I really enjoy talking about it with the students, it might be something that could be a very good exam question. So we have cases where we have anemia. Anemia refers that we have low oxygen concentration in the blood. And there's some symptoms that I have listed there: being tired, being pale, getting chills, and low in energy, and so on and so on. But really, there's many different reasons why one might end up with anemia. Anemia is often just a sign of something else that's happening. It can be that we're losing a lot of blood, which causes us to become anemic. It might be that we are losing that blood suddenly, or it might be chronic long-term loss of the blood. And that's a little bit of different in terms of how severely, how quickly we need to react, and how do we react on these issues. The other cause could be that there's not enough red blood cells being produced. So your red blood cells do an okay job, but there's just not enough of those around. Or the third reason, that your body is overly eagerly deleting, destroying the red blood cells. Of course, old red blood cells get removed, but it might be that that process is not in the balance with the amount of what's being made and what's being removed. The third one is highlighted on blue just because that was the last concept that I was explaining on your lecture video. So all of those three are important. But there is a special type of anemia that's of an interest to me. Many of my friends work with parasites and immunology and so on, and work on for example, on Africa and sub-Saharan Africa, on diseases that we find there. And I don't know how many of you have heard about sickle cell anemia. Well, sickle cell anemia is a result of a just single base in the DNA structure being changed, which causes then one single amino acid to be changed in the red blood cell, but it totally changes the shape of the red blood cell. So rather than being this nice round big concave disc, now it becomes a sickle shape, like a moon when it's not a full moon. And this shape is problematic for us. This shape is problematic because it doesn't allow those red blood cells to carry as much oxygen as the normal shaped red blood cells. The other problem that comes with this shape is that these shaped red blood cells often get caught. They are not able to pass through the smallest of blood vessels, and they end up getting caught on their path. So why am I interested about this? Why do I think that sickle cell anemia is so cool? Well, I don't think I have a picture of that. We end up finding, and I recommend that you have a look of that if you're not familiar on the actual lecture material. We end up finding that sickle cell anemia is very common at the areas of sub-Saharan Africa where we have malaria being common as well. And you remember malaria parasite, one of the stages of its life cycle is to enter to the red blood cells. So why would we have these two things going on together? And we even see that this is a genetic predisposition because individuals who have African heritage are often more likely to also be diagnosed with sickle cell anemia. Well, it turns out that sickled cells, red blood cells, still carry some amount of oxygen, just not the optimal amount of oxygen. But by being sickled shaped, the malaria parasite is unable to enter into those cells. So you could almost think of it as a protective function against of this parasite. So that's the thing with the biology and with the nature. Something that we think as a harmful or disadvantage can actually be an advantage in another sense. So that's one of the interesting concepts that I think highlights how biology is much more complex than we often give it credit for. And I think that would be a really, really good exam question as well. So that's what I wanted to say about red blood cells. Any questions about those? In that case, I jump. Go ahead. Can it lead into stroke? Absolutely. There is a higher chance if you have, I'm trying to post that, if you have sickled cells that you would end up with a stroke. The other causes, and we'll talk about those clinical adaptations really, really briefly, but would be if you end up, for example, producing more red blood cells than you would normally produce. And that would be controlled by a hormone EPO. And some athletes take EPO, so that they would produce more red blood cells, so they would be able to transport more oxygen, so they would outperform their colleagues. So although it's not just bad and cheating, it can lead into a stroke. Sickle cells just as well. But I think that's not, I wouldn't say that because you have a sickle cell anemia, you're definitely going to have a stroke, but you are more likely, you have a greater disposition. That was a really good question. Any other questions? Well, shout out even later on if you have a question. I'm going to show
monkeys eat bananas. So that might help.
Oh, I didn't mean to include the actual video that I was putting on this this slide. But what we see next is white blood cells. White blood cells, we have 5 different ones that we want to know. And they are here listed based on how common they are in blood. Neutrophils, lymphocytes, monosites, eosinophils, and basophils. Would I expect you to be able to identify different ones? Well, I go through how to identify them on the lecture video, and I also will provide a nice handout for that. I would expect you to be able to identify them if you have an open book exam. Would I expect you to remember those by heart? Probably not. But what I would expect you to remember is that what's the most common white blood cell and what's the least common. And the mnemonic that I use for that is to organize them based on how common they are and looking at their first letters. And that makes to me a sentence, never let monkeys eat bananas. So I'm all about mnemonics. So consider that if that might help you to remember them. And I think that that about covers the key concepts that I had. I do want to highlight in terms of the clinical stuff that I had marked here. just a few different things. We have talked about the cardiovascular system and function of the blood a little bit. We have looked at the composition, and then we have reviewed each of the plasma, red blood cells, white blood cells, and platelets. The clinical relationship with these, I'll just give you a quick run through of what I've highlighted here. All of these will be covered on your lecture videos, but I think that it helps when you kind of know what you're looking for in the lecture videos. Well, first of all, I want to say smoking is bad. Smoking is not just bad for the many other reasons that smoking is bad, but smoking is bad because carbon monoxide ends up replacing the oxygens that the hemoglobin would normally carry. So it blocks us from being able to carry as much oxygen into your body. So that's something that has a direct relevance to what we have already discussed. The other thing that I wanted to mention that we can end up with if we have too little red blood cells or if we have too much red blood cells. We can talk either about hypoxia, too little, or if we have too much red blood cells, we end up with very viscous fluid. So the blood becomes the viscosity of the blood grows up. EPO, erythropoietin, is a hormone. And EPO was the one that I already mentioned quickly that your body normally produces, and EPO promotes red blood cell production. However, many athletes misuse that by getting a lot of red blood cells produced in their body. That has a theoretical advantage that you would be able to carry more oxygen to your muscles, and that would allow your muscles to perform better than other competitors. You can achieve this effect without cheating, without breaking the rules, by going to high altitude. Over there, your body will eventually start to produce EPO and higher amount of red blood cells. And that is allowed in athletics. So many athletes go before important games to spend time on a higher altitude on purpose. The anemia, I already highlighted 3 different reasons for anemia. If your blood volume is decreasing because you're losing blood, your red blood cell production is low, or too much red blood cells are being removed. I talked with you about the sickle cell anemia a little bit, and that's one that I would encourage you to look into. And then in terms of the white blood cells, leukemia is one that we often hear people talking about. In leukemia, we have a high amount of white blood cells, which is indicative of that. The opposite of that as a clinical situation would be known as leukopenia. And the final concept that we did not cover on this review, but I have pretty good video for you that I recorded earlier on, and I even made a practical adaptation of that practical video where I actually do the blood typing on a recording. So I would encourage you to have a look of those. That's also part of your assignments for this week. You'll learn all about blood typing as a lab, virtual lab. So that's all I have in terms of the assignments and material that you have for today. But I think that many of you might be interested about, how about next week? How about the exam? What do I need to know? So if you don't have any questions about the actual lecture material, I would like us to jump into the kind of a briefing of what to expect from the exam. But feel free to shout out if you have questions. Review session will be recorded. I'll try to do it first thing on the Monday morning for that reason that I want you to have a chance to see that before you take the exam. So exam is available for entire week. And on the review session, I will cover every single question that will come up in your exam. However, I won't cover only those. I will cover also more than that. So just watching that is not me giving you answers just as it is. You have to kind of work through that. I really encourage, if you have a chance to taking part on one of the review sessions, but I do realize that everyone has lives and things to do. But I definitely offer the Monday morning, and I'm thinking of offering also Monday evening one review session. If you have preferred time on Monday evening, you are the ones who are here. You can now shout out, and I'll pick that time. Well, while we're thinking of that, I'll talk a little bit what to expect in an exam. So the reason why we're doing 4 different exams and the finals is that I want to have only a small amount for you to cram. I don't want you to feel that there's everything's riding on one single exam and it's do or die. So we will be covering only these 2 chapters on this first exam. So chapter 17 and 18, endocrine and blood. I think that those were the chapter numbers. I might be getting the chapter numbers wrong, but we will cover the endocrine system and we will cover the blood. And what's in the actual exam is only the material from the lecture videos. There are going to be easier questions and there are going to be tougher questions. But the idea is that really I'm not throwing you curveballs. I don't want you to have to do memorization. There are going to be some questions that are automatically graded, multiple choice, matching, ordering. But I do always try to include at least one short answer essay. So that's like just a 1 paragraph, some sentences, not a full-on real essay, but to have a little bit of also application. So it's not just memorization. I would recommend that even though you have your notes and you can take this exam from home, the first exam I do it that there's no proctoring on it. But even though you have all that, it is worthwhile to revise for that exam for the reason that if you don't revise for it, you're going to struggle to find the content that you're looking for. And you'll be browsing through the notes, looking through the videos time and time and time again. We don't want to do that. We want you to know the content and then know how to apply it. So the questions are not always just as clear-cut that, oh, this was mentioned word for word in the presentations. So there's 50 questions, and the questions are only from the material that's been covered in the lecture videos. And probably these live synchronous weekly meetings are also a good clue of the things that I think that are important and might come up in the exam. Same goes for the review session. Like I said, you can take it from home. It's open book. What are the exact questions? I'm yet to write the exam, so I'm almost finished with it, but I can't yet exactly answer to that question, but I will be able to answer exactly to that on Monday. If you feel that you can't attend to the review session or review session doesn't work for you, do remember that I'm more than happy to take time as an independent tutoring session with you guys as well, if you want to do it one-on-one or as a small group or as a whole class. All you need to do is let me know. And like I said, last week was rather hectic for me, but I will be easier to reach this week. So I really encourage you, you to let me know where I can assist you. So that's the exam. And often students are really stressed out about that. But if you spend some time on these videos with me, you'll notice that I'm not really super big on stressing students out. I'm all about trying to get you to learn. So exam on its own can be a learning chance. So that's why I'm all for open book exams. The second part of what we will be doing next week is the practical one. And again, I will provide a review session, will include the material from the practical one as well. And this is more of a traditional exam that you're used to. there are 25 questions, which are basically just fill in the blank. And they will be simply identification of things. So things that you have seen on your labs on the Connect. So they are pictures and you identify various different things from those pictures. I don't want you to be totally freaked out about spelling. You've seen me, you've heard me speaking. Spelling is not probably my strongest point, so I definitely would not punish or deduct points from anyone else if it makes sense to me that you know what you're talking about. Sometimes some students even tell me something else than the actual term if they don't remember the term that I'm looking. And I'm like, okay, I can tell that they know what they're talking about, even though they don't remember the exact word. The practical is timed, so you only have 30 minutes. But really, if you think about that, that's more than a minute per question. And in identification tests, you either know the answer or you don't know the answer. There's very little anything in between most of the time. It's not like by thinking about it, the answer will come to you magically. So either you know it or you don't know it. So minute per question is plenty enough. I think that I was just gonna do the review session, but I can do a study guide. I think your study guide really would be the study guides that I have posted. And then the intended learning outcomes that have been posted. But if you feel that you would be less stressed, I am open to putting together a study guide. Is that the general consensus that everyone would like to have a study guide also for the practical? Yes, I love that. Okay, I'm all about not having you stressing, so let me make a note for myself. I will put together something so you don't have to stress about it. I really think that what's important for me is this, that especially this first exam, that you have a chance to take it without stressing. And then you know when you go to the second exam and second practical exactly what to expect. So again, this is going to be open book. You're going to be able to take it from wherever you wish. And again, I don't put that as proctored, but it is that you might want to have had a look of those things that I list in the study guide. The exam due date, that's a good question. There's nothing to be sorry. So exams are due at the end of next week. So on the Sunday at 11:59 p.m. So they are open for the entire week. So you can pick when you want to do them. I probably will provide also a practice exam for the practical. I have a feeling that that would be helpful. I'm kind of sensing that that's freaking out students more than it should. Then when you've taken, okay, we'll do the practice exam then as well. So I'll do a practice practical so you get a chance to see exactly what's there. That's not going to add points to your final grade, the practice one, but you'll see where you're standing. You'll see the format, and I think I'll set it up also so that you can try it multiple times. So don't stress. Really, I'm not here to catch you. I'm not here to trick you. I want you all to do well, and everything isn't riding on one single exam. If you have a reason why you cannot, yeah, we're just focusing on the exam. There's no other assignments, so you'll do the exam and you'll do the practice. Those are the only things I ask you to do. And that's why I don't want you to feel that I'm bombarding you with a big ask. I want you to feel that you have time to prepare, you have a chance to go and complete that. I would advise, though, that don't leave it on the Sunday evening for 10 o'clock. Because every time that if students do that, their internet goes down or Canvas goes down or something else. And I don't want anyone to stress over that. However, if that were to happen, email me, because I monitor my email very, very closely when it's the exam time, because I know that things happen. And if it is timed single attempt exam, I have to go and behind the scenes open it up for you again if there's been a technical issue. So don't feel that you've totally lost it if there's a technical hiccup, or if there is something else that happens to you, if you possibly just cannot in any way to complete the exam next week. I am willing to work with you, but you have to contact me before the final deadline. If you contact me after the deadline, I'm going to have really hard time justifying why to give an extension. And I really do recommend that you get it out of the way, the exam and practical. So that's what I had about the exam and practical. Any other questions? Those all have been really good questions. Like I said, there will be a review session for those. And remember, for the exam, it's all about the material in the lecture videos. And for the practical, it's all about identifying things from pictures. What you've been doing on Connect. Finally, I do want to say about the Cranium Cafe, the tutoring service that we have for you. I've talked about it earlier on. There's no appointment needed. You can actually pick the tutor that you feel that you connect with. But I also want to say that I'm here to help you. Just let me know and I will make myself available for you. We'll schedule a time. It can be you alone. It can be a bigger group. It can be you and your neighbor if you want. I don't really care. I am here to help you. So if that's something that you think that would assist you, help you, do let me know. Will I post the exam link on Canvas? Yeah, I will post it. It's not up there yet for a reason that I'm still building it, but it's all gonna be on the Canvas. So no logging into Connect, nothing weird. And if you were to have any trouble finding anything, do let me know. Normally, I'm really good about the exams and practicals, having them open first thing on Monday morning. I think that the floor is yours if there's any other questions. You've asked really good questions. Is there anything else that's on your mind? PowerPoint presentations for... So basically what I normally do, your textbook is electronic, so you should be able to use that. I normally don't post the actual slides that I've done because what I share on YouTube has to be fully my own material so I don't get into trouble for copyright issues. But if you think that having PowerPoint slides available would help, I can look some of the older PowerPoint slides that I have. I just have to be careful that I don't give ones that are from a different textbook than what you're using. But is that something that would eliminate stress if you have PowerPoint slides to revise from? Maybe not. Okay, no, I'm all about it. If you're here, I will make sure that there's something. You know what I'll do, I'll post PowerPoint slides of a version that's almost similar to what I've done. It just doesn't have the same pictures. I'm just really paranoid about getting sued for using pictures from a different textbook than what you're using. So I will upload some sort of a... It might be PDFs. That way I don't get into as much trouble. But I will definitely have something uploaded. I'll upload them under each learning module as well as materials. I definitely want to go out my way for anyone who asks for something.
Thank you. Appreciate it.
Of course. Anything else that you guys can think of?
No, that's all for me. Thank you.
Okay, sounds great. So we've covered what we set out to do. I know that you have full days, full programs. I will have the lecture videos. I will have this video also uploaded by the end of today. It's just that my YouTube account is probably having a meltdown with the amount of uploading that I'm doing there. So it might take a couple of hours, but it will all be there. Thank you for joining me. I do have always a record who's been here with me, so I also take that into account when I do the final grade. So you're in a good place. And at any time, reach out for me. Remember, on Monday, there's gonna be also revision sessions for the exam and practical. Thank you for all of you for joining, and have a good rest of the week. Thank you.